Hi, 8th grade. Welcome to your last lesson of Topic 6, Angle, Angles, Triangle, Similarity. By the end of the lesson, I want you to be able to say, I can use angle measures to determine whether two triangles are similar. Let's explore it. Justin made two flags for his model sailboat. Draw and label triangles to represent each flag. Okay, so the first one, the striped one, red and white, I'll do in red. And all we know about the red and white one is that the top angle is 46 degrees. Drawing the blue triangle, I know the bottom is 4 and the sides are 5. I also know that the angle measures are 67 and 67. How are the side lengths of the triangles related? They're the same shape, they're just different sizes. So the side lengths are similar. We would just have to do a dilation. How are the angle measurements of the triangles related? Well, if I know that the bottom two of the blue one are 67, I can find what the third one is by doing 67 plus 67, which gives me 134. And then by subtracting that from 180 to find the top side. And that gives me 46. So the top angle of the blue triangle is 46, which is the same as the top angle of the red triangle. So the angle measurements of the triangles are congruent. They are equivalent. Justin makes a third flag that has sides that are shorter than the sides of the small flag. Two of the angles for each flag measure the same. Are the third angles for each flag the same measure? Explain. So, say he makes the smaller flag and he chooses to use the 46 degrees and the 67 degrees. I use black so you can see that better. Or say he chooses to use the 67. Let me find a color that you can actually see. 67 and 67. Well, in both cases, when you find the missing triangle, this will end up being 67, the missing angle. This will end up being 46. So the third angles for each flag are the same measure. Yes, because triangles always equal 180 degrees. Example number 1. Determine whether triangles are similar. Justin designs another pair of flags for another model sailboat. The larger flag is 1.5 times the size of the smaller flag. How can Justin determine whether the triangles represent the flags are similar? Remember, figures that are similar if a sequence of rotations, reflections, and translations and dilations maps one figure onto the other. So draw and label triangles to represent the flags. Then find a sequence of transformations that maps one pair onto the other. So first they did rotation. Then they did a dilation. So rotated and dilation. So yes, it is similar. Remember this squiggly line means similar. Is triangle XYZ similar to triangle LMN? So remember that the order matters. The measure of angle X, we don't know it yet. We're going to find it. So we're going to add 92 plus 42 to give us 134. So the measure of angle X is 134. And now we're going to do the other one, 92. Oh, what did I do wrong? Go back. That's not the third angle. The third angle, I still have to subtract from 180. 180 minus 134 is equal to 46. So this is 46. So measure of angle X is 46. on trying to find the measure of angle N, I'm going to add 92 plus 53 to give me 145. Now to find that angle, I have to subtract that from 180, and that's going to give me 35. So the triangles are not similar. They do not have the same angle measures. Even though they both have 92, the other two angles are not similar. So use what you know about transformations and parallel lines to explain why the angle-angle criterion is true for all triangles. So if there are two angles that are congruent, go back to this, I forgot to do the generalization. If two angles of a triangle are congruent to the corresponding angles of another triangle, the triangles are similar. This is called the angle-angle criterion. So if they have at least two angles that are the same, the triangles are similar. Here they had one angle that was the same, but they did not have two angles. So knowing what I know about transformations and parallel lines, if you have two angles that line up and are congruent, the third will be 2. Because of the fact that all angles of a triangle add up to 180 degrees. Example number 2. Are the triangles similar? Explain. Well, here we've got 70 and 70 and 50 and 50. So yes, by the angle-angle criterion, AA, the triangle MNP is similar to ABC. Looking at the part B, I see 42, and I don't see a 42 on the other side, so I'm going to hold off on the 42. But I do see that they both have 85. But I don't know about the third angle. Yeah, 42 is not equal to 45, but let's check out what happens when we find the third angle. So I do 42 plus 85, and that gives me 127. So then I take 180 and I subtract 127, and that gives me 53. Well, guess what? I don't have a 53 on the other angle. They did the same thing and they found that this was 50. So there's not two angles, so XYZ is not similar to RST. If QR is parallel to YZ, is triangle XYZ similar to triangle XRQ? Explain. Well, first I know that this angle and this angle is congruent because of, so I'll call it angle X and angle X. And that's congruent because of what? Vertical angles. And then I also know that triangle, or angle R is congruent to angle Y because of alternate interior angles. All right. So are the triangles similar? Yes, because there's one angle that's congruent, two angles that are congruent. So yes, because they have two congruent corresponding angles. We call that the angle-angle criterion. Example number 3, solve problems involving similar triangles. Step 1, if triangle ABC is similar to EDC, what are the values of X and Y? So first we're going to solve for the value of X, but I see these two together. 2X plus 1X has to equal 180. They make a straight line. So that means 3X is equal to 180 by combining like terms. divide both sides by 3, and x equals 60. So if x equals 60, that tells me that this is 60. And knowing that A is congruent to E, I know that this down here is 84. And the one in the middle has to also be 60 because of vertical angles. So I know 84 plus 60 plus 3y has to be equal to 180. Combine like terms, 84 plus 60 is 144 plus 3y equals 180. Subtract 144 from both sides, and 3y equals 36, which means y equals 12 when we divide both sides by 3. Find the value of x if the two triangles are similar and explain. Well, I'm going to draw this a little bit bigger so that I can write inside of it. This here means that the angle is 90 degrees. So that's 90. If that one's 90, so is this one because of vertical angles. This here means that the angles are congruent. If the angles are congruent, they're worth the same amount. So that smaller triangle up top is x plus 90 has to equal 180. Combining like terms, that's 2x's plus 90 equals 180. Subtracting 90 from both sides to work to get the x by itself cancels out. We get 2x equals 90. And then dividing by 2, x has to equal 45. Oh, I should not have used the variable x. Let's change that to b and b. b plus b, 2b, or not 2b. So b equals 45, which tells me that this has to equal 45 and this has to equal 45 if they are similar. So then this 45 matches up with our 15x. So now we are going to solve for x. Do you see why I wanted to use a different variable? So 45 has to equal 15x. Solving for x, we're just going to divide by 15. So x equals 3. Cool. Key concept, the angle-angle criterion states that if two angles in one triangle are congruent to two angles in another triangle, the two triangles are similar. Okie dokie, 8th grade, let's say it. I can use angle measures to determine whether two triangles are similar. Have a great day.